Good morning. Or whatever it is, wherever you are. All right, I want to do a little bit more research. Last night I actually did a little bit. I didn't know how it would be long enough to be worth streaming. Essentially, I looked up the Signal Protocol, which seems to be fairly well regarded by security people, or at least the main author of Squirrel. They didn't really have a complete treatment. They had a lot of things about pieces, which I'm guessing that they're more about the individual pieces of crypto. And what I found is that their signature algorithm is basically looked at Curve, one of two, one of which is the same as Squirrel uses. And didn't find a whole lot about necessarily the identity management of that. But I did see some stuff about Spider Open. I looked at that briefly before. What I did get is that you have accounts. Accounts have keys to all kinds of stuff, and there was some level of indirection within accounts, which is going to be somewhat similar to what Squirrel is doing. And I just want to understand that a little bit better. Okay, we've got libsodium, which that itself might mean that elliptic curves are in place. Now, this is a very different application than just authentication, but as a chat system, it's going to include authentication. Secure protocol, forward secrecy, minimal trust of server. Publish source code toolchain and build instructions. Well, then it's probably more for the server components. But, well, and use do not trust the binaries. It could actually cover the app. So in theory, you could look it up there if you needed to. So authentication in the Squirrel context is referring to client and server. Encryption key, all public created with the default libsodium values, ciphers, and protocols. Well, libsodium, that pretty much means encrypted curve, I think. But, well, they might support other things, I'm not sure. Although, scrypt, well, even Squirrel uses scrypt in a stage in its local store encryption. Because the identity hash tree is the part that's interesting here. Should be able to be verified. Well, no, this is for verification. Hash attributes account is tied to the server. Keyring is tied to the account. Event record, which includes some messages are tied to events. Anyway, that's not our primary focus. Server data structure. Oh, two attributes. Server name, host name. Well, that seems like more than two attributes. That's like 6 attributes. Signature key pair. Keys used for verification of server messages. Combining the above server attributes. Service port, host name, server name. Recovery key, that's very similar to what Squirrel does. So that's a similarity. Recovery key, creating 7 randomly chosen words. 32-bit output is generated to the following parameters. Input, the recovery key. Straight up words, huh? Salt, combination of the server's identity. Use an HMAC key derivation function to generate 2 items. Seed bytes, used for the account authentication key pair. Level 1 secret key, symmetric key used in the event of account compromise. There is something in there about account compromise. And did I get this link before? I did not. Seed bytes, authentication key pair, level 1 secret key. Count authentication key pair, public key, started the server. Count never stored in any device. How do you not store the secret key in any device? Oh, it's never stored in plain text, I assume. Level 2 secret key of random, used for encryption of an account's communication keyring. Stored in plain text on the user's device. Stored on server after being encrypted by level 1 secret key. Oh, right. You encrypt. The user has it. They encrypt it on the server. Then you put your recovery key in. Hash it back down to get the secret key. And retrieve it from the server. That's not entirely indifferent from what Skrill does. It's not strictly encryption. Account identity hash. Account parent. Identity alias. Account creation time. And a token, which is essentially nonce. Authentication key pair. Secret key is encryption of the keyring, which they use to decrypt stuff. No, what I don't get is the account authentication secret key, never stored on any device. I guess you only generate it in emergencies with the recovery key? Stores all root communication keys, keyring parent, previous keyring. Oh, that's for rotation, which lets you upgraded, keyrings, I guess, have most of the important things associated with a identity. And this might be that they're storing explicit keys, whereas Squirrel does procedural generation of keys. Yeah, I'd be copying this entire block of stuff. This is already pretty dense text. I guess for our purposes, account recovery key, set of words similar to what MetaMask does. So then we are KDF, HMAC, to get public keys and encryption keys. Regular use, secret stored on server, encrypted by recovery derived secret. Most keys stored in key rings, which support rotation with parent references. Encryption key pair, asymmetric encryption to this account. Tip channel session keys, signing key pair. Oh, okay. So then the stuff, there's a public key, which I guess is so you can identify yourself when you're doing emergency recovery. But then for your regular day-to-day stuff, you just make a signing key pair and store it in the key ring. Self-signature. Okay, and then these are less interesting. Signature made over the above. By the author, I guess? Member event. Or empty at the first record. Author keyring, account keyring. Identity hash of the user is being modified. Account state. Okay, so they're doing a little bit of a blockchain type thing with this, I guess. Set of changes with updates. Author keyring, I guess the author signs it. Привет, Alex Wolf. How are you today? And then these structures are all pretty much the same. Channel session key. Encrypted symmetric key shared between members of the channel. The modification of a member role, member departing the channel. Oh, yeah. Session key is rotated by the first member to send a message following the event. Not contain the symmetric key which is created by the user. Does that contain the channel session key share data structure? Oh, okay. So it's a reference to another structure. Handle session key share. And this is all the messaging stuff. This is LTSS. Then add as part of the message plain text. The server parses them and pushes notifications. Yeah, they just said it uses libsodium defaults. They didn't really say exactly, but I know that there's like crypto sign, which I believe is what Squirrel is effectively using, albeit in occasionally custom ways. Oh, and I keep forgetting there's no further beeps. Uh-oh, well, I'm sorry. I hope your day improves. So I want to talk about Squirrel in particular, but I saw some similar concepts in how Ethereum was working. So I want to broaden it a bit and look at some of the other sort of newer generation authentication technology. And indeed, I am seeing elliptic curves and all over the place. I was kind of hoping to look for broader stuff, but I've not been broad enough, and I don't really have time to go hunt down everything. But this is basically confirming that Squirrel was on the right track, even if it doesn't become the ultimate dominant standard. And ARG5, thank you for the host. So this was just me getting a more detailed, slightly more detailed understanding of this stuff. I don't know if I just need to copy that, because I can just bring up this reference. But maybe somewhere further down, I will need to like diagram this out. So, and then, sort of diagram out what Squirrel is doing, and I don't know if there's going to be a good way to do that on the stream per se. Maybe I could do a sort of outline format of how things relate, and it could kind of work. But the main point is that they both do some key derivation and have recovery codes of a form. And I think that is one of those attributes of this kind of next generation authentication, particularly with user responsible for private keys. Yeah, this is going to be a very technical topic, so I imagine it will be very challenging in translation because you're getting a lot of less common technical words. So the other main topic I wanted to cover, the whole public-private key thing relates to how SSH works, and that's just like a really old protocol. That might not be a bad place to start. Remote login. SSH tries to provide a secure channel itself, but they're going to have to do authentication as part of that. Let's definition, public key cryptography. They're assuming that they use, well, maybe newer versions can use the... yes, I've done most of my presentation and work with Squirrel on this laptop, so that is where I want to continue keeping everything, in particular because of the presentation software here. And I'm probably going to have to start outlining this tomorrow, if not, well, we'll see how time goes today. One is to use automatically to simply encrypt a network connection, and the other is to use password authentication. Okay, so cryptography to authenticate the remote computer, and then allow it to authenticate the user if necessary. Okay, so that's a significant deal. Do I have anything for SSH in here yet? No. SSH. Public keys to authenticate server, then and server authenticates user commonly by password. So it is a similar concept, but it is servers rather than users. Another is to use a manually generated public-private key to perform the authentication. Oh, that's the automatic format, allowing users or programs to log in. Okay. So we have auto mode. Or user key mode, which is what we're familiar with .ssh, ID, RSA stuff. Public key is placed on all computers that must allow access to the owner of the mentioned private key. The owner keeps the authentication is based on private key. Never transferred the network. Only verifies whether the same person offering the public key also owns the mentioned private key. Unknown public keys. Key management. Yep, there's .ssh, authorized keys. Only if it is not writable. Gets pressed in the remote and the matching private keys in the Lickland is no longer required. The private key can be locked. It specifies command line option. And that's the whole different key change warning. Incompatible SH1. Default key exchange, strong identity checking, message authentication codes. Supports both 2.0 and prior. And its version is 199. Oh, really? Oh. Mm-hmm. Found what? Okay, so OSSH to OSSH. We have mostly just open SSH. Seems to maintain supports SSH2, having expunged SSH1. Okay. Ah, okay. Yep. Okay, architecture. Well, this is packet level, but it might. Oh man, that's a very tiny diagram. And a very big diagram. Okay. Random padding. Payload padding length. Random padding. Random padding length. Oh, and then the message authentication code over that. And a sequence number. Okay. Did lose our place though. Initial key exchange is sort of server authentication. The upper layer, interface. I have not been talking about sausages. Unfortunately, I'm not sure exactly where that was. Messages, maybe? Key re-exchange. Ah. User authentication layer. Client driven. Maybe an SSH client prompting, not the server. Password. Public key. DSA and RSA. Okay, yep. DSA, RSA certificates is what we currently support. Seven nine, right? So I'm still going to look up into. Hmm. Okay, there's a second document on this, the Authentication Protocol. That might be of interest to browse. Probably straightforward. It's not a competition. There is a local, sort of technology user group. We got onto the topic of blockchain and authentication last time, and I mentioned that I'd done stuff with Squirrel. So I want to talk about Squirrel in the context of related things and trends. Make it a little bit more generic than just this one crazy standard. Server draws the attend the client. Which authentication methods can be used to continue the exchange? Try the method listed in the server in any order. Ah, the names are defined in SSH Arch. Is reserved. The none method is reserved and must not be listed as supported. It may be sent by the client. The server must always reject this request. It must be a leftover from SSH1. Oh, sending this request is to get the list of supported methods from the server. Okay. So you get the if it fails, it sends the methods, and none is a thing. Okay. Timeout for authentication and disconnect. Service name. Public key required. None, not recommended. Okay, if rejected. Server accepts it, must respond to the following. Public key. User auth request, username, service name, public key algorithm name, and public key blob. Oh. Are defined in transport layer, apparently. Now that's public key blob. Does that include the signature? Public key algorithm name from the request, public key blob from the request, from the actual client may then send a signature. Aha, okay. So this is a two-step process, actually similar to what Squirrels had at times. Username, service name, public key algorithm name, public key signature. Now the server is not providing a nonce here. Maybe that's something that's provided by the transport layer. With the following data: session identifier, username, service name, public key, signature over. Okay, so there's not an explicit nonce in here. And then we're less interested in the rest. Okay, that's pretty much what I expected. It's just a straight up sign a very standard message. And there is a little multi-step process. Multiple exchanges, standardized signed text, no explicit nonce. Other docs, maybe there's counting on the transport security to keep things safe. All right, so I may have to see if I can find time to set up a camera for my more post-it based method, but in the meantime, those are some of the major things I wanted to look into. So now we have to kind of scatter shot. What are we going to be talking about? So public-private keys are really popular. Elliptic curves, libsodium comes up a lot. So we have recovery in Squirrel. We have recovery in Semaphore. I might need to look up some other parts of the signal stuff to see if they have anything about that. So we have the concept of, so we've got public-private keys. We've got, these are all elliptic curves, so they're kind of, this is where we get the 256 bits is the new black, which I've got a quote for. Auth0 turned out to be kind of a bust. They have their own little thing. As far as I can tell, their Ethereum app is abandoned. We could possibly be looking at browser authentication, where we have MetaMask doing script injection. Squirrel uses on page.js or Squirrel scheme. Well, or QR code. I'm not used to doing things out this way. So let's see, we've got to, I probably am going to have to get to post-it notes, but I'm going to have to rearrange a fair bit of stuff to make it practical right now, I think. In the meantime, so let's take a look at some of the major features of Squirrel. We've got, what do we got? Oh, public-private keys. This is also going to get us into, well, it kind of crosses these two topics. User responsibility. Maybe it gets into a little bit of that. Because private keys, you're the only person who has them, depends on the service. Multiple levels of keys, so that's which is covering account recovery. So in Squirrel, we know that we've got, all right, so actually I need to update titles because I am not necessarily doing research anymore. We are now doing outlining. Outlining for authentication, presentation. All right. Title updated. So for Squirrel in particular, and I might want to start, this one I'm going to refer back to my existing stuff. Let's see, we have public, well, it is public private key. So well, this is going to cross back and forth. So server has nothing secret to lose, which is kind of a general, one of the big things about I want to highlight about this next generation cryptography or authentication. Are you moving to what? So in the Squirrel context, we have per server keys. This makes greater anonymity possible, but not necessarily required. I don't know if we're going to get I am running a bunch of, basically, well, the laptop isn't as fast, so I am running like the video monitors and chat stuff on the other computer. So that's also where I have, well, the browser dashboards pulled up where I edit titles and things. At some point we do want to touch on what are the unique properties of this. Like, I know for the Squirrel curve, you can use anything as private key. We have, I need to look up the information on efficiency. Part of that goes into the 256 bits. Probably want to talk a little bit about recovery. We've already got recovery in Squirrel. I'm trying to remember what Squirrel's main selling points are. So we've got public keys, so the server has nothing to lose. That's a big one. We've got, well, I've already mentioned it elsewhere, but we've got the sort of offline master key. Client security recommendations. I forget what they're calling it. It's like is it the unlock key? Makes the identity master key that you use day to day, and that is used to create the per server keys. So in Bitcoin and Ethereum, we have elliptic curves, we have the ability to sign things, we have the sort of user experience. We might want to compare that to using password managers, which is actually kind of... Oh, another thing about SSH, I know I used... So essentially we have agents. I'm not doing anything particular with Bitcoin right now. I'm mainly interested in the cryptography of it. The blockchain part, probably less interesting to my current applications, although you could use that to record login events and stuff, I suppose. And agents is also something else we can tie back to SSH. Why did oh, I was looking at the OBS logs. So we're going to start with previous presentation. Use that as a baseline. All right, so we got passwords. Passwords are problematic. We can, oh, you know what? We can stay out. That's one of the things I was thinking of. Layout. Threats. We have loss of server database, particularly with reference to passwords. I should probably say theft. Threats indeed, yes. You have theft of server database. We have man-in-the-middle attacks. We have theft of user info. We have loss of user info. We have cross-site tracking. Theft of other databases with same user, and sometimes even not same user. So this is one thing we can look at, is what are the threats that are, when we're structuring this, what are the threats that are plaguing current systems? And how would a next generation authentication system answer these kinds of threats? So that is what I was thinking is a way that we could structure this. And then I have to figure out if I want to take these one by one and then talk about all the points, or if we need to talk about these features and then go back to which threats they address. So in our previous generation, we've got, password methods, which are shared secrets, which are an issue. And then this was more focused on Squirrel in particular. And I might, if I'm going for next generation, I might want to change the theming of this. But so we've got weak passwords. Actually, that's another threat model. Theft of user info, loss of user info, weak passwords, weak authentication, e.g. bad passwords. We've got reuse, which is the other database thing, loss of information, so it's a rotten thing. Database exfiltration and cross-site database. I forget where I want this list. I think it's unique identification, but anonymous, which goes back to this cross-site tracking. So we could play this up, but we have the complication. We start getting into multi-factor authentication and all this crazy stuff. That you watch 3 people. On the channel. Well, I've got the chat up because I'm experimenting with cross-streaming to YouTube, because there is this thing called Watch Me Work that had the guy come in here one day, but they only do YouTube Live. So today I'm testing YouTube Live, and if that seems to work, maybe I can try that out as I continue working on this and the other programming projects. I'm not sure what else you might be referring to. All right, so we might be able to play up the complexities of two-factor and stuff. Okay, so this is actually a little bit similar. I'm going to go into public-private key cryptography. Oh, I did talk about SSH as an existing model. And here's the user experience. Okay, and this was up. I guess this is Squirrel answering all that. Okay, identity master key uses the hashing mashup. So we've got a way to do that. I guess that's what gives us that's the unique per site to answer the cross-site tracking. Site key, identity key, oh, yep. So this is more Squirrel-specific stuff. We might get into that. This is a Ruby-specific stuff. And this is actually out of date. The untrusted computer case. It's kind of under man in the middle. Untrusted computers, keyloggers. And then I've got all the old information. All right, so this is the cryptography stuff, which maybe I can touch on as we talk about the curves and stuff. This is much more detailed protocol stuff. But developing the Ruby thing. This could be interesting to touch on. Second loop might actually be going away. I need to refresh myself on that. No, I am trying Restream, which goes to YouTube as well. Since I've never done that before, I don't really expect anybody to be watching me there. Okay, this is all down in the dirty squirrel details that I don't think is going to be relevant to what I'm going for with this one. There's 256 new black. Oh, and sync. Oh, AES. Okay, cool. Yeah, this is the client security stuff. Client storage format. I can maybe touch some of that stuff. Identity unlock protocol. Which is, I could probably only touch on it. This gets really hard to do, and then offline storage. All right, so I got a couple extra themes there. So I guess the thing now would be, do we process this as the major technologies and themes, which I haven't had coalesce yet. And I guess there's public-private keys, but then that kind of ties into user responsibility for the key and how you've got agents doing the signing for you and keeping those keys. All right, so theft of server database gets answered with public keys. Theft of other databases. Well, the public keys sure help, and using unique per server helps even more. So we're going to go with network man in the middle. This is where you do nonces for one. And I'm going to have to probably spend some time reviewing the squirrel stuff, but specifically where they talk about how you defeat that. Squirrel in particular uses domain-based keys, which helps a lot. IP checking. This is the QR code / cross-device authentication in Squirrel's case. That would not work so well with the Ethereum's MetaMask. Weak authentication is answered by using public keys where the user doesn't choose anything. Now you still have the issues, with agent private key protection. You could talk a little bit about maybe how Squirrel does that. So theft of the user info, that's encrypt the private keys, multi-level keys. This is just multi-level keys and offline storage. Cross-site tracking is unique per site keys. They could still ask for email, etc. Hard to use. Yeah, it's hard to use. We do have some nice workflows, but there's some setup involved. Typical case can be streamlined. Setup is hard because of user responsibility and offline backup, etc. So this might be something we could work with. I'm going to have to decide how we order things so that we tend to be talking about similar themes. You know, for instance, when we introduce public keys, I'm going to have to look at the things you want to hit on public keys. And then, so with the curve, we've got, I might actually want to start with some of the, like, weak passwords. Because that can start pointing us towards, like, the Ethereum model where it's just, okay, you've got to, well, yeah, so weak passwords and theft databases are like some of the most obvious things that we can attack with this. cross-site tracking is a little bit more of a squirrel-specific thing. We can probably do that later. This kind of goes in with weak passwords. Untrusted computers is... it goes along with attacks. Maybe we want to deal with these farther down somewhere. Although untrusted computers gets a little bit into the ease of use stuff. The fact that you can do that. So mainly it's about ordering. Well, we start to move some of this stuff up to where we want to talk about it. So we've got so the two starting points are probably loss of database and weak authentication with passwords. I'm not sure which to start with there. And then once we get into the topic of public keys, we can talk about its relation to the blockchains, which also use public keys and happen to use elliptic curves in most cases, typically using the 256-bit keys that are very common. And that will be one of our major themes of what is a next-generation authentication system. So theft of server database is the big one, and maybe what we do is we actually kind of lump these together. And Doggen Lake, holy cow, I didn't know, hello, are you actually there? That seems big enough to be a real stream. Of course, I've noticed from my own hosts that it's often showing me hosting with several more people than I saw when I left. But yeah, I'm not aware that he streams in the morning. Anyway. Could be a day off, I don't know. But yeah, he is a cool guy. I kind of got sucked into him playing Oxygen Not Included. Lately, he's been doing Into the Breach and 1 Hour, 1 Life. Actually, that reminds me, I have to hook YouTube up to that stuff. All right, anyway. So I think we're going to lump those together because basically they both get answered with public keys. The cross database stuff, you're protected from actual account leakage. Now, the only thing is that they could correlate, if it's the same public key, they could correlate information from multiple sources to, de-anonymize you on one server. That's more about cross-site tracking. So there's two levels to this. Did I hear a beep? Oh, okay. I don't believe I've heard of that one, no. Okay, and that's the same thing. So we've got two aspects to this. Straight up cross-site tracking and theft of database from some same user could do correlations. That's been part of the problem with server databases, but it starts to get into other aspects of what Squirrel does that I consider a step above the basic use of public keys with elliptic curves. Maybe what we want to do is do this and then move into the concept of agents. And then set up password managers. Or password managers into agents. Okay, we could set up weak authentication. We can set up password managers as one possible solution, and then look at theft of server databases as a threat model that even with the password manager giving you strong passwords, that will set up the sort of authentication agent as a trend. And to a certain extent, that's what like the SMS and second factor things are doing. They're bringing in a sort of your password database is a thing you have, kinda-ish. So we have theft of server database. If you're using strong passwords to begin with, the cross-site isn't as big of an issue there. All the public keys are, well, if you have database compromise, they can get email. Many people use the same email for everything. And that is that. All right, I would like to take a short break. I'll be back in a minute or two. All right, so I have to get to the other window. There's other monitor. Da, 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 da. Welcome back. Yeah, yeah, OBS, or maybe it's just this computer that has the mic and desktop audio position switch, which always confuses me. Of course, I also found out that OBS doesn't, by default, capture desktop audio. That's something I have to play around with later. And okay, so users could still use a weak password on their vault. That we could get into like the hardware tokens and things. Oh, you know what? The other thing I wanted to look into was some of the, well, I mean, I know that the whole FIDO thing is focused on second factors, and it's kind of a big complicated mess, last I heard. So then we have theft of server databases, which is where we start talking about public keys, having agents. We have the Ethereum process acting as your interface. Now I don't know, so I don't know where I want to do this. Well, so we got public keys, which gets us into elliptic curve. And which, well, elliptic curve is going to be a major theme of this, I think. Which we essentially get this. I might want to touch on libsodium as a fairly common thread across this. Oh, you know what? This kind of gets into the theft of user info. Yeah, this falls into a little bit of the agent-based stuff. So that becomes a sort of an awkward transition. Let's see, so other themes, user responsibility. So yeah, multiple levels of keys. How the recovery process works. Though theft and loss might get kind of lumped together with some specialized stuff thrown in. But this sort of multi-level offline is another theme. I'm just trying to figure out. That kind of goes in with the whole agent thing. But I was looking at setting up the concept of an agent and then going into, instead of storing passwords, we store private keys, and which we can do public keys. And then some of this other stuff is a little bit more advanced. And maybe when I say get everything worked out, it could even fall off the end if we don't have time for it. Do we do agents by themselves? Well, you can talk about, you still have to encrypt, I mean, encrypting passwords, encrypting keys, all kinds of falls under the same umbrella. I do not know the expression per se. I think I like it because that's kind of what Wondable is. It's wonderful and terrible at the same time. I sort of think of it as like a hack that is in some ways horrifying and in some ways amazing. You know, which might be doing something really cool in a terrible way. I don't know if you could also do something terrible in a really cool way. I don't know. Anyway, I made up a word. It seemed like it made a useful handle. Ah, okay. Yeah, terrible is sometimes used as a superlative. I don't think I would call that a common expression in particular. But I guess I could see somebody, saying you are terribly beautiful, and that would, if you were complimenting someone, it would make sense in context. So do we put the agent-based stuff with loss of user info, well, and with ease of use, because they're kind of streamlining that. Or do we introduce public-private keys and then say, well, okay, this is how you use that, because you pretty much have to have an agent to perform the signatures. It's not something you're just going to, pull out a pencil and work out a cryptographic signature on your own. I mean, password managers are a theme in and of themselves. But I'm trying to figure out if I can talk about some of these other things. You can't really talk about multi-level keys. And offline storage goes into the multi-level keys. They pretty much relate to some of the things you can do with public-private key cryptography. I think hard to use, we're going to be primarily looking at somewhere in here we also have to consider the SIM attacks as well. I don't know if that's a separate point or not, but it's sort of the challenge to like second factor as a panacea to, or a solution to these things. Where do we put second factor attacks? Like stealing your phone number and stuff to get second factor codes. That goes a little bit into hard to use because you have to set up these apps and it's different for you have to use an SMS with your email and an authenticator with your bank, and you have to keep track of that and not lose it. So now you've got multiple things that could potentially, multiple points of failure. I guess theft of user info becomes a bigger deal when you've got an agent. Lost, they could just forget a password. See, theft is a little bit more advanced because you also have to consider shutting down the old information. Oh, and I'm not really sure which category this goes into. It's kind of a replay attack, so it would go into MetaMask signing changes. Because yesterday I ran into a method where I tried to do a sign, and it's like, oh, well, this is unsupported because it allows people to try to get you to sign incorrect things that you might not want them to do. So I still need to break out all my points. Well, I have to figure out how much content I've got. So I don't know, I might... There's still some things I can think about, but I'm starting to wonder if I should break off early, start trying to figure out the setup for the big post-it board. We can maybe try to do that tomorrow. So the big thing, the big structural issue I've got right now is ordering of like agents versus public keys. This is kind of getting into the agent stuff. Public-private keys kind of imply user responsibility. Which gets us into loss and theft. Ma- some of these other things are more advanced topics. Cross-site tracking is a topic a little bit more specific to Squirrel. So it's not necessarily a trend, although I guess trying to get rid of ad trackers and such is a trend. Although there is going to be, actually, that's a good point. Somebody else is going to be doing a presentation on, was it GPDR? General Data Protection Regulation. Export of personal data outside the EU. I don't know if this is directly relevant. I just want to take a quick look to see if anything that touches on that sort of cross-site correlation, which this helps to reduce. The cost of strict compliance regime was severe, up to 4% worldwide turnover. Okay, well. So it's a big fee, but like it's not something, like if my turnover is 0, it's not a lot for me. The data controller or processor or an organization is based on the UA. Also applies to organizations based if they collect or process data on individuals located inside the EU. As to his personal, professional, public life. Name, address, photo, email address, bank details, posts, computer's IP address. I don't know if they include a public key. It's relating, but it's sort of an abstract thing. Obviously, it does not apply to the national security agencies. Why would we do such a silly thing? Yeah, it's not super relevant to me. Single setter with all EU member states. Hmm. Data protection measures should be designed into the development of business processes for products and services. Pseudonymizing personal data. Well, if you're only known by a public key, that helps a little bit. But if they're storing names and addresses, it's not really pseudonymous anymore, is it? Well, okay, so authentication would certainly be performance of something they've requested. Let's say a contract. There would probably be a consent on the thing. And of course, the problem is that they're talking about consent, and everybody clicks through the agreements anyway. Pseudomodernization, personal data to a specific data subject without the use of additional information. Oh, encryption, okay. Kept separately. Tokenization. Brave New World. Presented by default. Set at a high level by default. It's going to make a lot of stuff really expensive. And I could see a lot of companies just not servicing the EU at this point. All right, I didn't see anything in there that would be specifically relevant to whether public keys matter or cross-referencing public keys matter. Designing so data doesn't need protection. Data minimization. IP address. Without having leaked personal identifiers per se. Okay. All right, I haven't been able to pick anything useful out of that. All right, let me chat. So we've got agents and devices. We've got public keys. Maybe hard to use should be more like user error. That's a little bit more into UI design and such. All right, this is a very Squirrel specific thing. So I don't know if I necessarily need to touch on the ease of use. That's one of the arguments for Squirrel, but it's not sort of my broader theme of what is the next generation authentication going to have? Well, we're seeing this trend towards like you've got your Ethereum wallet or a Squirrel client that is going to acting as an agent. We've got public keys with an awful lot of elliptic curves showing up. Actually, cross-site tracking and privacy. That's why I was getting to this, because we've got the GPDR. So if we're looking for big themes, we've kind of got that. And then once you've got an agent, you can always have a loss of user info. User forgets their password. And multi-level keys are really related to public key specifically, so it has to be structurally after that. So one of the alternates to passwords, or at least to having lots of passwords, is the OAuth and company, where you authenticate with a third party, but that third party becomes a master of all the information about what you're doing. A lot of this touches on exactly how Squirrel does its keying. So if I want to treat that as a point of discussion, I have to discuss public keys first. So that sets up an ordering between those. I was thinking agents first because that sets up that is a feature, and then that feature well supports public keys. If we've already said that we want to move away from passwords and towards public keys, then password managers are not even a relevant thing. Although they're sort of a ban. I guess I could circle back and say, well, until we get public key crypto, you could still use an agent sort of by using a password manager. Actually, I could set up agents as a way to implement both of these things, because that makes it easy to use different passwords at each site to cut some of the database stuff. And then that flows more smoothly into, well, you've got an agent that is your repository of all your info. What happens if you lose it? What happens if it's stolen? And the rest of this stuff will become more as time allows. So we could talk about agents down there. But that would actually move the weak authentication or bad password threat kind of completely out of scope once you've talked about public keys. And said, well, this is better because, well, we can circle back and say it's also better because I want to talk about agents. We talk about that after because password managers allow you to keep multiple per. But that's where I would be talking about the squirrel-specific feature of hashing in the domain name of the site in order to defeat cross-site tracking. Maybe I just have to, If you mentioned sets of databases, we can get into using separate passwords, using password managers. And if I wanted to use the cross-site topic to talk about unique per-site keys in Squirrel, I have to have talked about public keys. That has a clear dependence. Having agents at the end makes a better connection to loss and theft of the user side information, or the user database. But we'd have to kind of float the whole topic of where do you store the private key? And it's like, we're going to set up this case for using public keys and then return to bad passwords? I guess we could frame it as another thing that this protects against is bad passwords. Yes, I'm a little bit stumped right now. This might be kind of, well, partly I don't know if I want to say sleep on it, but I need to let that churn a bit. And I want to see if I can get a setup where I can do my post-it board, because this is probably about, well, if it's a 30-minute presentation, we got about 30 lines on here. And that's like about 1/4 of the resolution I'd usually go to laying things out. So it seems like I usually will do like 4 slides per minute-ish. So I want to get that set up, look back at my previous presentation for where I have things that relate to that, to relate to these points, and then look at where we need to expand detail. I mean, like multi-level keys is going to get into a big topic of how Squirrel does it and how Semaphore does it. I can probably expand on the elliptic curves using and both MetaMask and Squirrel as agents. But getting that and maybe starting to kind of run through things will tell me a lot of where the flow of information is incorrect and where I need to add detail and where we're going to run to our time limit. But yeah, I'm feeling really cramped by the text file here. And of course, that's going to require a little bit of setup. So I think that's it for now. Nope, still on this computer. The stream is here, the chat is not. So that is it. It's going to be a little bit short just because I didn't end up doing quite as much research as I thought. I guess I could go look at FIDO stuff, but that might be more of an extra credit thing for later. So thanks to, and it moves. One Jelly Beans, Throw Me Ice Leopard, Dog and Lake, McRhyme, Osserat Gaming, Catnox, Arg5, XDS Dev for hosting me. I expect to be back later this afternoon for Astroneer and, okay, I can quick reference that. Interesting. All right, so let me do a quick check-in here. All right, so looks like Tacos X is playing Astroneer. He's hosted me before. Now, I've not had a chance to get in and look at him yet, so I can't necessarily speak to the quality of the stream yet. But he came in, he said hi, and he's been hosting me. So I think I'm going to go have a look so I can better judge that in the future. So I need to be in my dashboard. Go there. And then we need to get over here. So yeah, I'm playing Astroneer this afternoon. Thursday, we might see the Oxygen Not Included preview. If it looks interesting, I'll jump into that. If not, I'll probably be doing, I don't know, maybe it's time to get into, I'm forgetting the name of it now. Anyway, Zombie RTS. Or 1 Hour, 1 Life. Seems like playing that looks interesting. That's it for me. If you're looking for someplace to hang out, you can check out Tacos X, and bye-bye.